Right, there's question 5. So you are going to have a titration. In the conical flask, there is sodium hydroxide, and in the burette, there is sulfuric acid. So this is sodium hydroxide react or have with methyl orange. So first, you are going to request to write the equation between sodium hydroxide and sulfuric acid, like this. And next is the X. Okay, so we have come across X is burette. And finally, you are going to ask what is the color at the start of titration. It is methyl orange in alkaline, so it is yellow. So given the same dilute NaOH and sulfuric acid, how can you prepare pure dry? You should highlight the crystal. So first, we should, after calculation, we should put the same amount of sulfuric acid, but this time without indicator. Let's write down like this. You will feel free to use chemical formula to save your time. Next, the product should be contain salt and water only. So what should we do is simple. Heat the solution, cool down, and filter. Because you are requested to form a pure crystal, so we should highlight this is cool down slowly. Well, finally, how can we obtain the crystal? Yes, dry it or filter it, wash it, and dry it. Okay, here we go, like this. So here, let's highlight the key point. Heat the solution to concentrate, cool down in room temperature slowly, filter, wash with little cold distilled water, and dry the crystal in desiccator to guarantee we have hydrated sample. Next is question 6. Now this time you are prepared again pure dry sample of lead 2 chloride from lead 2 nitrate. Now, but the difference from question 5 is this time your crystal is formed from precipitation. So you should have different preparation method. Many of you forget this word, solid. Now your lead 2 nitrate is soluble, okay, no problem. But this time you start with solid. So the first point is you should dissolve your lead 2 nitrate into a solution. Well, next point is you need to find a suitable source for chloride ion. So sodium chloride is a good choice, right? But don't forget, you should use sodium chloride in aqueous form. And here, bracket AQ is good enough. And finally, what you want is you filter the mixture and obtain the residue. Wash it and dry it again. And that is, okay, again, let's highlight the key point. Key point is first, dissolve, and then mix with NaCl. Finally is filter, wash with distilled water, and dry it in desiccator again. For question 7, so you are prepare a sample of copper 2 nitrate. So what we do is put excess copper 2 oxide into dilute nitric acid. This is a neutralization. For potassium nitrate, this time we do titration between potassium hydroxide and nitric acid. Okay, there are 2 sets of reactions. First, reaction between copper 2 oxide and nitric acid. So let's write down. And the second one is reaction between potassium hydroxide and nitric acid. Why different method? The difference is because the copper 2 oxide is a solid which can be removed easily, but potassium hydroxide cannot be removed easily by filtration, and that's the problem. Or that's why we need to use different method. So if copper 2 oxide is insoluble, they can be removed easily by filtration. So that's why we should calculate or find something to make the exact volume of potassium hydroxide needed for the titration. Here are the marks, okay? First, you need to mention their solubility difference, okay? And next one, so the result is copper 2 oxide can be removed easily, but KOH cannot. And here is for the fundamental part.